Hi everyone, today I want to give an update on GoExploit. And if you're not familiar with GoExploit, it's the exploitation framework that Vulncheck's initial access team develops. It's Go based and it's open source, so you can check it out anytime you want. The thing I want to talk about today is a new C2 that we introduced. GoExploit is kind of neat in that it has a very configurable C2 system, so we're always looking to add new and interesting C2. This one is sort of basic, but it's interesting. It's called ShellTunnel. And what it does is basically it catches a reverse shell, and then it will forward the contents to a true command and control. And it will pass the data back and forth so that basically you have a shell proxy. The way that plays out is, let's say you're an attacker with GoExploit on this firewall. And you've exploited the victim who sends a reverse shell back to you. GoExploit can now just send the shell traffic to the true command and control. This is great because then the victim doesn't actually ever connect to the command and control. It connects to the attacker box. So there's separation there. And if there's like egress rules, this might be useful. So the whole point of this video is I kind of want to show off how this works with a real life example. And so we're going to use one of the exploits we made public here. This is CVE-2023-22527, which is a CVE I really like. We actually wrote a long blog about it called Confluence Streams of Shells. But we updated this particular exploit, the reverse shell, to use tunnel shell if we wanted to. And that turned out to be a very easy update. This is the diff. And all we did was bump the GoExploit version, and we appended this C2 ShellTunnel to the supported C2. And that's all it took. It just works otherwise. So we are going to recreate this right now. So let me show you the different boxes. I will go right to left. So first is the victim, and it's a Windows box. We have Confluence installed on here. It's 10.9.49.13. I guess to sort of prove that Windows is installed, I do have it pulled up in, that Confluence is installed. I have it pulled up in a browser, so it's on 8090. Next is the attacker box, and I'm actually showing you all of this from the attacker box. And I have this nice tab that even says it's the attacker box, and you can see that we're at 10.9.49.12. And then last but not least is the command and control server that we want to forward everything to, and this is at .192. So let's go back to the attacker box, and I don't actually have this exploit installed at the moment, so let's go grab it. Like I said, this is open source, so you're free to check this out yourself. And I said the reverse shell, right? Yeah. So we just make this. So one neat thing about GoExploit, or what I think is neat, is that it's self-documenting. So I can say, give me the details of this binary. I can also tell it to log JSON, so I can just pipe it out to JQ here. And it will tell me everything about its implementation. And you can see that one of the supported C2 is the ShellTunnel. Another fun thing with GoExploit is that it has a version scanner and asset detection stubs built in, so to encourage the exploit developers to actually fill those out. So just to make sure that Confluence is up and running and it's a vulnerable version, we'll run this little command that will do that. -C is basically to check that the asset is there, and just V is version scanning. So you can see that, yes, we verify the target is up, and that is running a vulnerable version of Confluence. So we'll move right on to exploitation, which is kind of long, but I will explain it. So -E is exploit in GoExploit. -R hosts is the remote target. So as we discussed earlier, .13.8090. So those are set. lhost will be the attacker box because we want the Confluence server to connect back to the attacker box and want the attacker box to connect to the command and control. So we'll listen on port 1270. And by default, GoExploit will always use the first C2 in this list, so we have to tell the system to use the ShellTunnel, and then we give it this particular connect back host. This is who we want to connect back to, and remember this is our command and control, which I believe I'm going to need to start the listener on, which I haven't done yet. So you can see we're using Netcat with SSL enabled. So we actually have to tell the C2 about that. So this is C connect back SSL enabled. This is sort of interesting in that the connect back from Confluence is going to be unencrypted, and we will actually see this in Wireshark. The connect back from Confluence will be unencrypted, but we'll have an encrypted connection back to the command and control. So exploitation is very quick. You see the exploit says that it caught a new shell from Confluence and that it was able to connect back to 1.92. But that timeout's expected. So let's see if we actually have a shell over here. Looks like we do. It should be a Windows shell. Let's see. So we're not lying. .13. Who are we? We're network service. So very good. So that all worked very nicely. Let's take a look at Wireshark. We'll start this up. So you can see the connection between .12, the attacker box, and .192, which is the command and control is encrypted. We should be able to find unencrypted traffic somewhere. So this should be communication between the Confluence server and the attacker box. And you can see it is unencrypted as I said it would be. We could have had an encrypted traffic as well, but I want to show off that we are actually forwarding this data type thing. Yeah, so that is the ShellTunnel. I think it's a neat new little feature that requires very little to update old exploits with. If you think that sort of thing is interesting, we are always looking for new and fun C2 like this. Like I said, GoExploit is an open source project, and we're very happy to see pull requests. So thanks for learning something new about GoExploit, and I'll catch you next time.